Okay, so today we're going to talk about properties of soils. I'm redoing all these from last year to try to condense this down so you don't have to watch as much of it. So you're welcome. Okay, so in order for soil to be fertile, it has to do a few things. Okay, so in order to grow life, plants, right? It has to be able to retain enough water and nutrients for plants to grow. It's got to be able to drain away excess water because otherwise plant roots will suffocate if they get waterlogged. And it has to have enough aeration so that microbes can thrive in it and engage in nitrogen fixation, all the other steps in the nitrogen cycle. So, one of the main things we concern ourselves when it comes to soil is porosity and permeability. So, as I said in the previous screencast, porosity is the space between the mineral particles that can be filled with water and air. And typically, what we have is air with water adhering to the surfaces of the mineral particles. And this is important because in fertile soils, what we have is an adequate amount of pore space where plants can put their roots in here so they can hold themselves in place. They can breathe the air that's in here, and they can absorb the water in order to engage in photosynthesis. So permeability is the ability of water to flow through these pores. And so basically, high permeability soils drain well, low permeability ones don't. And so if permeability gets very low, the soil becomes waterlogged, and this tends to kill plants and bacteria. But soils, if they have too high of permeability, say, then what happens? They drain too fast. They don't retain enough water or nutrients, and so then the plants basically can't live because they are deprived of necessary materials for photosynthesis and growth. So, what happens is humans have a tendency, unfortunately, to engage in certain agricultural practices and industrial practices that compact soil. So soil compaction is an issue we need to concern ourselves with. So, an uncompacted soil can grow a lot of plants, right? And the idea is if we squeeze the soil, what happens is I make these pores smaller and smaller and smaller. I squeeze out the pore spaces so there's less air that can be held in there. There's less water that can be in there, and the water that's in there doesn't drain very well. So it makes it difficult for roots to get into it. And when the roots get into there tends to be too much water logging in there that so that the roots suffocate. Uh, all right, so let's just look at how does that happen. Okay, how do we accidentally compact soil? Well, basically, the main ways we compact soil are by driving like heavy farm equipment on it, especially if it's wet. So think about this: when the soil is dry, the particles don't slip as much, right? Like just like cars don't slip as much on a dry road. But when it gets wet, like a car, the particles tend to slide a little bit, right? As they can slide past each other, and that's when they compact. So it's really important for farmers to monitor the moisture level of their farmland and not drive heavy equipment on it when it's wet, because once you compact it, it's really hard to undo that. Another way we do it is farmers have a tendency to till in order to get rid of weeds so that they can plant a new crop and not have them compete with these weeds. But that tilling action tends to reduce the porosity and tends to increase compaction. Another thing is just letting cattle walk on fields, especially if they're wet, has a tendency to increase the rate of compaction. So what happens is when a soil is healthy, the roots can grow through it easily. There's plenty of water, there's plenty of air, and you get good productivity. But when I compact the soil, there's less pore space. It's harder for the roots to work in there. There's less air in there because the pores are smaller, and the water doesn't drain as well. So those pores tend to become filled with water and waterlog, and then drown the roots. So it tends to greatly reduce productivity. Now, as we said yesterday, there's in the previous screencast, there's three sizes of particles that we concern ourselves with in soils. There's sand, there's silt, and there's clay. Now, the clay is actually considerably smaller than this. Okay, but in decreasing size, sand, silt, clay, and each of them plays an important role in soil. So let's look at them in turn. Okay, so sand is made of silicon dioxide. It's basically what like a beach. It's a component of most rocks. Okay, and it's very, very resistant to chemical weather. So it's like the last thing that stays. Everything else rots away to clays, and the sand is left. Okay, now here are the advantages of having sand in your soil. It reduces compaction. It's very good at holding the soils up and preventing them from compressing. And also, it has good drainage. There's a lot of it's fairly large. So there's big openings between the pores, which gives it high permeability and lets water flow through. The disadvantages of sandy soil are because it is so permeable, water drains right out of it. So if it's too sandy, the plants are going to end up dying of thirst, and the water that flows out tends to carry away nutrients. So it tends to be very low nutrients. So if you think about, a sand dune, it's kind of hard for plants to grow there because there's not much water in it and there's not much nutrients in it. Now, silt is basically chemically identical to sand, but it's much, much smaller. And because it's much smaller, it has a higher surface to volume ratio. So you get a collection of silt particles tends to hold water better. There's more adhesion going there. There's more surface area. So what we find is with silty soil, it's going to retain water better just because there's more surface area, and nutrients are often in the water. So by retaining water, I also retain nutrients. So the Nile River, in Egypt, the flooding of the Nile was so important because it would bring these nutrient-rich silts into the farm fields that the farmers would then, have add to the productivity of their crops. The disadvantages of, it says sandy, but I mean silty. Don't worry, I'll fix that. The disadvantages of silty soil, darn it, is that it doesn't drain well because it's smaller particles, so there's smaller openings between the pores, so the permeability is less. And so since it doesn't drain as well, it can become waterlogged, but it does drain a bit, but it also compacts more easily. And then there's clay. So clay is chemically different from sand and silt. It's made by the decomposition or alteration of a kind of mineral called feldspars into what are called clay minerals. These very flat, high surface area minerals. Uh, and here's the clay particles tend to be very, very tiny, and they have that negative charge on the outside, so they tend to be very good at holding on to water and nutrients. So the advantage of clay-rich soils is it's really good at retaining water, and it's really good at retaining nutrients. Unfortunately, it's really bad at draining. I mean, in fact, how do you, like, if you want to build a lake, right? So engineers say we're going to build a lake. What they have to do is they have to line the bottom of it with clay, because if you line it with clay, water just cannot infiltrate through that clay. It's absolutely not permeable if you get a thick enough layer of it. And also, it compacts very easily, and once it does, there's just no pore space whatsoever. So again, you have larger is sand, big grains means big openings, means big pores, means good permeability. Silt is the same chemical structure as sand, however, smaller particles. So the pores are smaller. There's more surface area to hold on to for water to adhere to, nutrients to adhere to, but the openings are smaller, so uh, it doesn't let water flow through as easy. It's not as permeable. And then when we get to clay, there's these flat plate-like minerals, and they tend to basically form an impermeable or a layer that which water simply cannot go through. And so it's just a question of size. Now, loam is what we call like sort of the ideal soil. So the ideal soil, and yes, you do have to know this for this class. Okay, the ideal soil is basically the perfect mixture of sand, silt, and clay. And it gives us the advantages of all three components. And so the proportions for loam, and no, you don't have to memorize this, would be 40% sand, 40% silt, and 20% clay. All right, a little bit of clay, too much clay, and it's not going to drain at all, but you need some clay to retain moisture. All right, now, so basically we see like say for if I have sandy soil, it has great aeration and drainage. It doesn't hold nutrients and water very well. It's pretty easy to work it to plant your plants. If I have a clay-rich soil, well, it doesn't have much aeration and it doesn't drain very well, but it sure holds on to nutrients and water well, but it's really difficult to work that soil and put plants in it. And loam basically has the advantages of both sand and clay. All right. So you do have to learn how to do this for the test. It's usually on the AP test, and that's how to use what's called a soil texture triangle to try to determine what category of soil we're dealing with. And you can see we have a number of different categories. You do not need to memorize these, but you do need to know how to use this triangle in order to determine what type of soil is present in an area. Let me show you how to do that. Okay, so to use the soil triangle, what you do is you'll either determine or be told what the percentage of sand, silt, and clay is. Okay, so I'm going to tell you in this particular example, it's 15% sand, 60% silt, and 25% clay. What you do is this. Let's start with sand. It's 15% sand. So I find the sand axis, which is here, okay? And I want to find out where 0 is for that axis. So this is 0 sand. So this line here represents 0 sand. I want to draw a line parallel to the 0 sand line. All right, at 15%. So I'm going to go from 0 to 15, and then I'm going to draw a line for the sand that's parallel to sand's 0 axis. That's crucial. If you don't do that, you get the wrong answer, okay? And I only need a second one. All right, so now I'm going to go to silt. I'd find silt. The silt axis is here. Here's 0 silt. So I'm going to draw a line parallel to this, but I'm going to go down till I get to 60, which is here, and then I'm going to draw a line that's parallel to silt's 0 line, and it intersects here. So I have a silty clay loam. Now I can draw that third one. I can go to clay, just for the sake of argument. I go to clay, it's 25%. Here's 0 clay. This is the clay axis. Here's 0. All right, so I need to draw a line that is I'm sorry. Here's 0 clay. Sorry about that. Here's 0 clay. All right, and I go from 0 to 100. So I'm going to go up to 25, and then I'm going to draw a line parallel to the 0 line for clay, which is here, and it intersects there. Okay. Yeah. Okay. We just did that. All right. Last thing, we'll be done here. Okay. So agricultural practices that leave soil exposed, that's bad. Anytime you see naked soil, that's bad. Okay. Bad things are going to happen. So you're going to get erosion, and the type of erosion you're going to get is either going to be wind erosion or water erosion. Let's look at the difference. Wind erosion tends to carry away the lighter components. That's going to be the clays and the silts, and so it's going to leave the soil with too much sand in it, so it's going to drain too easily. It's not going to retain moisture very well or nutrients. Now, one way of preventing, the best way to prevent this is not to leave soil bare. Always leave some plants on it, but people tend not to do that. But another thing to do is you can plant what are called windbreaks. You can plant trees in such a way that wind can't pick up a lot of speed, and that's been shown to greatly reduce the amount of wind erosion that occurs. And then water erosion happens, when I have bare soil, especially if it rains or if I just irrigate it, that as that water gets in motion, it tends to carry away not just the lighter components, but all of it, leaving these furrows or these like I don't know, like these valleys, and then just carries away everything, all of the topsoil, and that's a problem because without topsoil we can't have agriculture. So the best way to prevent that is to just never leave it bare. But the second thing you can do is use what's called contour plowing. So I plow perpendicular to the hillside rather than just in arbitrary lines, and that does have a tendency to make it harder for water to flow. I think that's it for this. Yeah, that's it for this one. Thanks for watching. And basically, I've been able to reduce your amount of screen time and save us a day of class. You are welcome.